Hello everybody, Sorbin here, and today we will be looking at the determinant, the adjoint of matrices, and also we will be looking at singular matrices. And at the end of this video, you should be able to find the determinant of matrix, find the adjoint of a matrix, and also use the concept of singular matrices or a singular matrix to answer questions. So first of all, let's head into the first topic, which is the determinant. Now the thing about the matrices topic, the thing about the topics on the matrices, subtopics on the matrices, most of them are abstract. Matrices fall under the abstract part of mathematics, in which you just have to understand, and the application at the CXC level, you won't really find an application there. It's just something that you need to remember. And that is why it's very simple, because the application questions for matrices, they will not be very challenging. You just need to know the concept of matrices and you can answer all kind of questions with matrix. So let's look at finding the determinant. So the determinant is calculated using the formula AD minus BC. And for A, B, and C, this is let's say we had a matrix A and we had elements A, B, C, and D. These are the positions in which these elements should be. A first, followed by B, followed by C, followed by D. So the formula is the determinant of, let's say, this matrix A would be whatever number is at A multiplied by the number at D, subtract B multiplied by C. As simple as that. So this is the symbol that you use for determinant, or sometimes you may even see, if you want to, so sometimes they may even give you it like this, the letter with the number inside. So sometimes they may even give you like this, with the capital letter with two strokes at the side. That also is telling you to find the determinant of that matrix. So if matrix B is equal to 1, 4, 2, and 3, find the determinant of B. And as I said, this is the symbol used for determinant, or they may even tell you find the determinant of B like this. So let's go. So the determinant of B is equal to AD minus BC. So this is A, this is B, this is C, and this is D. So the determinant here would be A, which is 1 multiplied by D, which is 3, subtract B, which is 4 multiplied by C, which is 2. So 1 times 3 would give us 3, subtract 4 times 2 would give us 8. So the determinant of B is equal to 3 subtract 8 would be negative 5. So the determinant of B is a negative 5. And that is how we find the determinant. So of course, let's look at another example of finding the determinant. So this one says, if matrix A is equal to 2, negative 3, 1, 3, find the determinant of A. So you want to find the determinant of A. So we know the formula of determinant is AD minus BC. So this is A, this is P, this is C, and this is D. So A would be 2 multiplied by D, which is 3, subtract B, which is a negative 3, multiplied by C, which is 1. So this would be 2 multiplied by 3 would be 6, subtract negative 3 times 1 would be a negative 3. So a negative and a negative, this will cancel out and give you a positive. So we now have 6 plus 3 is 9. So the determinant of A would be equal to 9 in this case. So you just need to pay keen attention to the signs when we are answering these questions. So now let's move on to the identity matrix. Now the thing about the identity matrix, what the identity matrix is that is the matrix in which you multiply by another matrix, you will get back the same matrix. Alright, so this is the identity matrix, which is 1, 0, 0, 1. If you multiply this matrix by another 2 by 2 matrix, the result will be 2, 1, 5, 1, because the identity matrix will produce when you multiply the same matrix. So to find the determinant of this matrix, what I can tell you, the determinant of the identity matrix is 1. Without even working this out, that is one thing you should know. The determinant is 1. Determinant is equal to 1. But let's just work it out so that you can see. So the determinant here, so the determinant of the identity matrix would be AD minus BC. This is A, this is B, this is C, this is D. So A is 1 multiplied by D, which is 1. Subtract B, which is 0, multiplied by C, which is 0. So 1 times 1 is 1. Subtract 0, which is equal to 1. So the determinant of the identity matrix is always equal to 1. That is one thing we should remember, as it comes a lot in CXC. So now let's move on to the adjoint of a matrix. So the adjoint of a matrix, that is simply found by rearranging the matrix and flipping some signs in the matrix. So if we had the matrix A and we want to find the adjoint of A, what we do, we switch these two. So wherever we have the A, we'll put the D. So we switch it, and this is how it becomes here. And then we flip the signs of these two. So because this is a positive, it will turn into a negative. Because this is a positive, it will turn into a negative. So we flip the signs and we switch the A and the D. Let's say we wanted to find the adjoint of this matrix. So the adjoint of this matrix would be, the adjoint would be equal to, so we flip these two, we switch these two, we switch the places of those two. So that where we have 4, we'll put 1. And where we have 1, we'll put 4. And then we flip the signs of these two. So this 3 will turn into a negative 3. And this 2 will turn into a positive 2. So the adjoint of 4, 3, negative 2, 1 would be this here. As easy as that. So of course I want to cement this with another example. So let's say we wanted to find the adjoint of this matrix, which is negative 2, negative 5, 6, and 1. So the adjoint of this would be, so we switch these two. Wherever we have 1, we'll put negative 2. Where we have negative 2, we'll put 1. So we'll put 1 here, negative 2 here. And then we flip the signs of these two. So this will become a positive 5. And this will become a negative 6. And this will be the adjoint of that matrix. And as simple as that. And that is how we find the adjoint. So next, I want to move on to singular matrix. Now, if a matrix is singular, then that simply means the determinant of that matrix is equal to 0. If the determinant of a matrix is 0, then that matrix is considered to be singular. So of course, we can use this concept to answer questions. But first, let's find the determinant of this matrix below. So we know it's AD. So the determinant would be AD minus BC. So AD would be 6 times 1, 6 times 1, subtract 3 times 2. 3 times 2 would be 6 times 1 is 6, subtract 3 times 2 is 6. 6 subtract 6 would be 0. So this matrix here is considered a singular matrix. So now let's use the concept of a singular matrix to answer this question. So given that the matrix below is singular, determine the value of x. So we already know when a matrix is singular, that means the determinant is equal to 0. So if you want to find the value of x and we are given this piece of information, let's do that. So the determinant here will be equal to AD minus BC. So in this case, we already know the determinant should be equal to 0. So now we can, so we know A would be 2 multiplied by D, which is x, subtract B, which is 4 multiplied by 1. So 0 will be equal to 2 times x would be 2x, subtract 4 times 1 is 4. So we can rewrite this as 2x subtract 4 is equal to 0. So to find the value for x, all we have now is a simple equation. So we just solve. So we know this 4 is subtracting, so when we take it over, it will add. So we'll have 2x is equal to positive 4. And this 2 is multiplying x, so when we take it over, it will divide. So we'll have x is equal to 4 divided by 2. So x will be equal to 2. So that is the value of x, and we can find that because the matrix is singular. So of course, let's look at another example. So given the matrix below is singular, determine the value of x. So we do the same thing like what we did just now. We know the determinant here would be AD minus BC. So we know this is A, this is B, this is C, and this is D. So we know the determinant here is 0 because the matrix is singular. So this will be 0 is equal to AD, which is 3x, multiplied by D, which is 1, subtract B, which is 2, multiplied by negative 3. So we can simplify this to be 3x times 1 is 3x. We can either do 2 times negative 3, which will give you a negative 6, and you have a negative and a negative together, or we can consider this 2 to be a negative 2. We just multiply it by the negative 3. A negative times a negative would be a positive. 2 times 3 would give you 6. So we have 0 is equal to 3x plus 6. So we know we can rewrite this as 3x plus 6 is equal to 0. So we solve now. So we take over this 6. The 6 is added. Now we take it over to subtract. So we'll have 3x is equal to a negative 6. And the 3 is multiplying the x. So we take it over, it will divide. So you'll have x is equal to negative 6 divided by 3. And negative 6 divided by 3. X will be equal to negative 2. So the value of x is negative 2. And with that, this has brought us to the end of this video. I trust that you now have a good understanding of how to find the determinant of matrix, how to find the adjoint, and also the concept of singular matrices. So remember, the determinant of the identity matrix, the 2 by 2 identity matrix, is 1. Of course, I must leave some for you to practice on your own. So you want to evaluate or find the determinant and the adjoint of these 2 matrices here. And then you want to find the value of k if this is a singular matrix. So with that, I'll end off here and I'll see you in the next video. Take care.